Right, okay, students, can you all hear me? Right. Okay, so good afternoon for everyone. Friends, today we are going to discuss Memory Boost paper number 6, right? So there are 15 MCQs to discuss here. So let's see what are the things we have discussed, right? Question number 1, what is the incorrect regarding cathode rays? So they have given 4 statements for question number 1. A, B, C, D, 4 statements are given. So let's see whether these statements are correct or wrong. They travel with the speed of light in vacuum. Is that correct? Remember, students, electrons are not uh, electromagnetic radiations. If electrons are electromagnetic radiations, then we could have considered this statement is correct. But since they have given cathode rays, this statement is wrong. Okay. Can I remember I told you that cathode rays means beta particles. Beta particles are traveling with which velocity? Beta particles, is that exactly what? Yes, 90%. 90% of velocity of light. So therefore, it's not velocity of light, 90% of velocity of light. They are negatively charged. That's correct, true. They bend towards the positively charged plate in electric field. Since they are negatively charged, that's true. They bend towards the north pole in the magnetic field. That's wrong. In a magnetic field, cathode rays bend perpendicular to the electric or magnetic field. Sorry, magnetic field. Okay. So therefore, B and C statements are correct. If B and C statements are correct, what is the option? I taught you how to get the answer for this one. B and C correct? Are they asking incorrect one? No. Friends, they are asking what is incorrect regarding cathode rays, right? So therefore, A and D are incorrect. If A and D incorrect, then we have to consider answer is number 4. Question number 1, answer is number 4. Raise your hand those who got the answer as number 4. Raise your hand those who got the answer as number 4. It's very easy. Huh? Good. Question number 2. The point or points that can be determined by using the successive ionization graph is electrons exist in the main energy level of atoms. Electron exist in the sub-energy levels of atoms. There are orbitals containing electrons in sub-energy levels. There can be 2 electrons in an orbital. Students, under the ionization energy analysis, I told you that, right? We discuss about the ionization energy analysis of the phosphorus atom, right? In order to discuss about the sub-energy level concept, we analyze the what ionization energy graph for the phosphorus atom. Now, we know that phosphorus electron configuration is 1s2, 2s2, 2p6, 3s2, 3p3, likewise. Then when we draw the graph was like this: 1s2, 2s2, so these are 2p6 electrons, 2s2, 2 6, PS2. Three P3. Can you remember? In this way, we drew this kind of a graph. Because in the ionization energy graph, I told you that we obtained three observations, right? There are no two particular points in the same energy level. That means you have to understand that each and every electron has different ionization energies. And the second one is actually the larger energy gaps. From these larger energy gaps, right? From these large energy gaps, I told you, we can understand the existence of the principal energy level. Existence of energy levels, principal energy levels, right? Then I told you that there were some slightly large energy gaps, right? Slightly larger energy gaps. In slightly large energy gaps, I told you that we are explaining the existence of sub-energy level. Existence of sub-energy levels, right? So therefore, you have to understand that here they have given electrons exist in the main energy level of atoms. Yeah, that's true. Electrons exist in sub-energy levels of atoms. That's also correct. Using the ionization energy graph, we can obtain that. There are orbitals containing electrons in sub-energy levels. Students, we don't discuss about the orbital existence in the ionization energy graph. Okay, so we discuss about the orbital existence using the Pauli's exclusion principle, then Hund's rule. So those are the theoretical concepts we discuss about the orbital existence, right? So using the ionization energy analysis, using the ionization energy graph, we are just understanding the existence of the principal energy levels and the sub-energy levels. How these electrons are located, distributed among these energy levels, how these electrons are located in sub-energy levels. So those things can be analyzed, right? So therefore the C statement is wrong. D, there can be two electrons in an orbital. Students, again, using the ionization energy graph, we can't obtain. We can't tell anything about the orbitals. So therefore, C and D wrong, A and B correct, right? So therefore, we can determine the existence of the energy levels and the sub-energy levels, number 1 and number 2, A and B correct. So therefore, answer is number 1. Okay, answer is number 1. Raise your hand, those who choose the answer as number 1. Raise your hand, those who has chosen answers number 1. Okay, good. Okay, right. Question number 3. The relatively stable electron configuration is R. Students, we discuss about the electron configuration, right? And we discuss about the stability also. By looking at the electron configuration, we can tell whether this configuration is stable or not. Okay. Now, if we consider S1 and S2 configurations, so without any doubts, we can tell that S2 configuration is stable. Okay. And remember, we know that when we consider P1, P2, P3, P4, P5, and P6, I told you that P3 configuration is half stable because there are 3 p orbitals, when the orbitals are filled by one electron in each, we can consider this is half stable, right? Symmetrical and half stable. If all the orbitals are filled with electrons, right? If there are three paired electrons, right? We know that according to the Pauli's exclusion principle, the maximum number of electrons are two in an orbital. And those two electrons cannot have a same set of quantum numbers, or else these two electrons are revolving around the nucleus to two different directions. So therefore, this is completely stable, right? This is stable because all the three p orbitals are filled with the electrons. So p3 and p6 also stable. Then when we go for the d configuration, d1, d2, d3, d4, d5, d5 is again half stable. Why? There are 5 d orbitals. Each orbital is filled with one electron. Then we can consider this is half stable, isn't it? This is half stable. Then we have d6, d6, d7, d8, d9, and d10. So in the d10 configuration, there are 5 orbitals: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is completely stable because all the 5 orbitals are filled with 2 electrons in each. So d10 is also stable. Now what are the options they have given? They have given 4 options here. ns2. Here n means any principal energy level, 1s2, 2s2, 3s2, likewise. And simple B is np2, C is np5, and D is nd5. Students, np2 and np5, they are not stable. You can see that. S2 configuration is stable. And they have given d5. D5 is not completely stable, but it is half stable, right? Compared to these two, anyhow, these two configurations, A and D, both of them are stable. So therefore, since they're asking relatively stable electron configurations, we can consider A and D are relatively stable compared to B and C. So A and D statements are correct. So therefore, answer is number. Raise your hand those who got the answers number 4. Good, very good. So we discussed these things in the electron configuration, right? If you have any doubts, put your doubts in the chat box. Right, okay. Question number 4. Some alpha rays deviated from the path in the gold leaf experiment. Yes, that's correct. In the fourth one, the first statement is correct. Students, I told you that we are having these kind of questions also in the exam. Now, I think this is the first time I'm adding this statement type of questions in the boxes, right? We know that from the question number 41 to 50, they are giving these kind of two statements in table, okay? And if you don't know that one, again, I will revise it. It's very simple. In A-level examination, our MCQ question patterns are a little bit different from the others. Question number 41 to 50. Remember, students, you are given two statements in this way, in the same row within two boxes. So here we have one statement. Let me consider statement number 1. And this is statement number 2. Remember, normally when they are giving these kind of statements in the paper, the professor that who making the paper, sometimes he is making a connection between these two statements. Sometimes there is no connection between these two statements. But anyhow, you have to check whether these things are true or false, right? You have to check whether this is true or false. Then how we can go for the answers in the answer sheet? Now, 1, 2, 3, 4. We have 4 options, 5 options. So the place that you have to choose, the first one is statement number 1 is correct. Statement number 1 is true. And statement 2 is also true. And second statement explains first statement. Then the answer that we have to choose is first one. Then the second option, right? So the second option is actually statement number 1 and 2. Both are correct. Both are correct. Both are true. And second statement doesn't explain first statement. Then we can see that the answer is number 2. That means, students, both the statements are true, but there is no connection between those statements, right? Third one is first statement is true and the second statement is false. Fourth one, first statement is false and the second statement is true. So you have to choose option number 5 when both the statements are false. Understood? Anyhow, you have to check whether these statements are true or false. Then if both of them are correct, then you have to check whether is the second statement explain first statement correctly. Understood? So that is the question patterns from question number 41 to 50 in our A-level exam paper. Okay, I'll discuss with you how to do our MCQ paper. In the paper class, we will be discussing these things. Okay, what are the tricks that we have to follow in order to do the paper? How we can manage the time? Time management is very, very important, right? Even in the MCQ paper. Essay paper is hard, right? Sometimes most of the students actually don't get 1,000 out of 1,000 for the essay paper. It's very hard. It's very difficult. Even some of the island rankers are taking 970, 980 out of 1,000, right? It is very difficult to get that kind of a mark for the essay paper within that limited time. Okay, right. So So students, the first statement is true, no? Some alpha rays deviated from their path in the gold leaf experiment, correct. There are positively charged nuclei in matter. Yeah, that's also correct. That's also correct. Second statement is also correct. Now tell me whether the second statement explains the first one or not. What do you think? Since there is a positively charged nuclei in the matter only, the alpha particles are deviated their path. Correct, ne? Can you understand the connection? Second one is explaining the first one, ne? Right? That means the second statement is the reason behind the first statement. Can you understand? So, why alpha particles are deviated from their path? Because of the positively charged nuclei at the center, inside atom. So, therefore, there are positively charged nuclei in matter, right? They could have told this one nuclei in atom. It's okay, fine. Let's take that one as atom, right? So, both the statements are correct, and the second statement is explain the first one. Therefore, question number 4 answers first one. Raise your hand, those who got the answer as the first one. Good. There are some students. Question number 5. Right? Question number 5. In the question number 5, they have given the Bohr theory can explain any atomic spectrum well. What do you think? Students, remember, Bohr theory is explaining the hydrogen emission spectrum. We use Bohr's theory to explain the hydrogen emission spectrum, and even using the hydrogen emission spectrum, we can say that the Bohr's theory is also correct. But remember, Bohr theory cannot be used to explain the spectrum of all the atoms, because I told you that, students, when we consider the emission spectrum or the absorption spectrum of the atoms, when the atom is larger, that is very complicated. If there are more number of electrons, it's very difficult to study. So therefore, Bohr's theory is not applicable all the time to analyze all the spectrum. We can simply analyze hydrogen emission spectrum, because hydrogen emission spectrum is containing only one electron. Even in that one electron system, we have so many possibilities. Just imagine there are now in the periodic table 118 elements. Just take the 50th element, team. So then there are 50 electrons. Then how many possibilities will be there? So therefore, Bohr's theory is not applicable to study all the spectrums. Hydrogen-like simple elements can be analyzed by Bohr theory. So therefore, the first statement that they have given, the Bohr theory can explain any atomic spectrum well, that's wrong. Second statement is wrong. First one, the Bohr model is used to describe the line spectrum of hydrogen. Now that's correct. We discussed that one. Because in the Bohr's theory, we know that electrons are going for high energy levels by absorbing energy, and coming back to the low energy level by releasing energy. So that's why the lines are obtained. So therefore, those things are correct. So for the hydrogen, it's okay. First statement is wrong. Second one is correct. Again, question number 5 answers fourth one. Raise your hand, those who got the answer as fourth one. Raise your hand, those who got the answer as fourth one. Good. Question number 6. Okay, that is also a very interesting question. Question number 6. Hund's rule is a principle relevant to the filling up of electrons. Is that correct? Students, what does mean by the Hund's rule? What we discuss under the Hund's rule? In the Hund's rule, I told you that when the electrons are filled to the orbitals, first of all, electrons are filled to each orbital one by one for the parallel spin, that means same direction electron. Then only the paired electron in each orbital will fill in this way. 1, 2, 3, same direction electron one by one to each orbital. Then only the second electron is going to the orbitals from the beginning again. So that's what known as Hund's rule. Yeah, we are talking about something related to the electron filling. The first statement is correct. Hund's rule, principle relevant to the filling up of electrons, that's true, correct. Next one, it states that the filling up of electrons the orbitals take place according to the increasing order of energy of the orbitals. That means, students, they are telling that Kunz rule states that when the electrons are filled to the orbitals, they are filling to the energy increasing order. Students, go for the Aufbau principle definition I gave you. This is actually the idea given in the Aufbau principle. In the Aufbau principle, we have some kind of unexpected filling order. No? We are expecting after 3p6, the electron should go for the 3d, but electrons are going for 4s. It is explained by the Aufbau principle. Then I told you that Aufbau principle is explained by the energy diagram. In that energy diagram, electrons are filling to the orbitals one by one for the increasing energy order, energy increasing order. So we learn that concept in the Aufbau principle. But here they are telling that it states, means Kunz rule states that electrons are filled to the orbitals for the direction where the energy increasing. It's not the Kunz rule. It's not what Kunz rule says. Okay? So that is Aufbau principle. So even though that idea is correct, but the idea is not given by the Kunz rule, it is given by Aufbau principle. Therefore, I'm going to consider the second statement is wrong. Okay, that's the way that now we have to do this kind of questions. Huh? Hereafter, each and every memory booster paper, you will have these kind of questions. Now, from the next week onwards, my plan is to give, now our A-level examination paper is 1 to 30, 31 to 40, 41 to 50. So there are some types of questions to here, right? That means here, we can consider this is type 1. That means completely 5 answers are there. So this is actually A, B, C, D statements. This is type 2. And 41 to 50, those boxes, statement type. Then type 3, right? So from the next week onwards, I'm going to insert to the paper from the type 1 5 MCQs, from the type 2 5 MCQs, type 3 5 MCQs. Remember, students, in the A-level paper, many students are making mistakes in these 20 questions only. Right? Many students, most of the students are doing these first 30 questions nicely. Definitely they are getting more than 20, no doubt about it, because that's easy. But when it goes for the 31 to 40, 41 to 50, here only the game is started. Right? So here only you will fall into a trouble. Especially 31 to 40. 41 to 50 is also fine, can manage. But 31 to 40 ABCD statements actually kind of what? It's a big trouble if you don't practice that one. Because students, there are so many options too. Right? So from the next week onwards, you will see that type 1, type 2, type 3, there are 3 types of questions in that paper. Okay? Let's see. Remember, students, the easiest way to go for chemistry A is do MCQs. MCQ paper is really easy. Okay, if you score more than 45, 46, 47 MCQs in the MCQ paper, then easily you can go for A. Right? If you can score 45, 46, 47 in the MCQ paper, even though your structured essay paper is not that much successful, but still you have a chance to go for A. That's why from the beginning, I'm focusing you all for the MCQ paper. Right? Find out papers and do MCQs. Right? If you have any doubts, we can discuss those things in the class. Right? So therefore, do MCQs. Huh? That's very important. Don't think that I'm not focusing on the structured essays and essay questions. When the paper class started, you will see that we are discussing structured essay and essay questions as well. But from the beginning, MCQ practice is very important because that is the easiest one. Let's finish the easiest one first of all, right? Second statement is wrong. Students, second statement is actually Aufbau principle. Question number 6, answer is third one. Raise your hand, those who got the answer as third one. Good, very good. Question number 7. The number of unpaired electrons present in Cr3+, nickel 2+, and copper 2+. Right? So let's write down the electron configuration of these three elements first of all. Chromium, nickel, and then we have copper. So chromium is 24, nickel is 28, and copper is 29. Electron configuration of chromium is 1s2, 2s2, 2p6, 3s2, 3p6. 3D, it should be 3D4, 4s2, but I told you that in order to obtain the greater stability, it is rearranging into 3D5, 4s1. And chromium's configuration is special, exceptional behavior. Now they're asking how many unpaired electrons in chromium 3 plus. Then Cr3 plus cation. Cation means it's removing 3 electrons. Then the configuration is 1s2, 2s2, 2p6, 3s2, 3p6. Remove the 3 electrons from the valence shell, 4s1, and we have to remove 2 electrons here also. Then the remaining thing is then 3d3. Students, 1s2, 2s2, 2p6, 3s2, 3p6, up to here, all the electrons are paired. In the d sub energy level, we know that there are 5 orbitals. Each and every orbital is filled with 1 electron except these 2 orbitals. They are empty, unoccupied d orbitals. Then you can count the unpaired electrons. So how many unpaired electrons? There are 3 unpaired electrons. Okay. Go for the nickel. What is the configuration of nickel? 1s2, 2s2, 2p6, 3s2, 3p6, 3d8, 4s2. So these electrons are paired, no? Right? Orbitals are completely filled, even the 4s2. Then we have to focus on 3d8. But remember, they're asking about nickel 2 plus. It's not nickel, nickel 2 plus. That means 1s2, 2s2, 2p6, 3s2, 3p6. When the electrons are removed, the electrons should be removed from the valence shell. Therefore, 3p6, 3d8. In the d sub energy level, there are 5 orbitals. 1, 2, 3, 4, 5, 6, 7, 8. Then 2 unpaired electrons. No? Unpaired electrons are 2. Copper. 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1 is the configuration of copper. And copper is also an exceptional behavior. We know that there are some exceptional electron configurations in the periodic table. What are they? Chromium, copper. And when we go for the 4D, we have starting from niobium, right? Then molybdenum, ruthenium, rhodium, palladium, silver, right? So likewise elements, those elements are having some exceptional behavior. Copper is producing here. They have given copper 2 plus. 1s2, 2s2, 2p6, 3s2, 3p6. Remove 2 electrons. 4s1 and here 3d9. Again in the d sub energy level, there are 9 electrons, means 1, 2, 3, 4, 5, 6, 7, 8, 9. How many unpaired electrons? Just 1 electron is there. True answer is 3, 2, 1. Question number 7, answer is second one. Raise your hand, those who got the answer, second one. Good, very good. So last week we discussed about the electron configuration, okay? Okay, question number 8 is also a good question from the electron configuration. Electronic configuration of last shells in element atom is 3d10, 4s2, 4p6, 5s2. Which of the following can be the element? Give me the answer. Friends, we wrote the electron configuration 5 times, no? From hydrogen to barium. Now you should be able to tell this one. What is this element? 4d10, 5s2. What is it? Yes. Shehani, your answer is correct. Very good. What about the others? Okay, now you have to put the answers in the chat box, huh? Yes, correct. Anjali, correct. Yes, Vinudi, correct. Yes. Anna, your answer is correct. Yes. Zainab, you are correct. Akira, your answer is correct. Harini, correct. Shabnam, your answer is correct. Ahmad, you are correct. Hansa, correct. Joella, check the answer again. Yes. Shakya, your answer is correct. Omaya, your answer is correct. Sehara, your answer is correct. Yeah, that is strontium, no? Students, answer is strontium. Electron configuration of strontium is 38th element in the periodic table. Strontium is 38 in the periodic table. 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 10, 20, 30, 36, 5s2. 4p6, 5s2. So this is strontium. Question number 8, answer is fifth one. Raise your hand, those who got the answers, fifth one. Good. Now, question number 9. Question number 9 is actually a good question. It's very interesting. Right? Question number 9 is a very good question. It's a very interesting question. Raise your hand, those who got the answer for question number 9. Okay, good. There are some students. And let me know your answer. Put your answers in the chat box. What is the answer for question number? Wow, very good. Yes. Who are they? Takira, your answer is correct. Well done. Zainab, your answer is correct. Shehani, your answer is correct. Good. Right. Yes. Harini, your answer is correct. Vinudi, you are correct. Ahansa, your answer is correct. Sehara, your answer is correct. Omaya, your answer is correct. Very good. Yes. Very interesting, right? That means you got the ideas. ඒ කියන්නේ ළමයි ඔයගලන්ට හිතන්න පුළුවන්. Right? So you people can think and do something, right? So I personally believe that 9th question is the hardest one in the paper. Okay, hardest ones in the mean sense you have to think there. It's very simple, but it is checking your intelligence. Okay. Now check you got the answer in this way. This is the data table that they have given. I2. This is I3. Students, now I1, I2, I3, I4 for 5 elements A, B, C, D, E. They have given like this. Now they are asking among these elements that belong to the same group in the periodic table. Remember students, the same group elements are having same chemical properties. For an example, now just imagine group number 1. Lithium, sodium, potassium, rubidium, cesium. Look at their configurations, will you? Lithium is 3, sodium is 11, potassium is 19. Configuration is 1s2, 2s1. Sodium is 1s2, 2s2, 2p6, 3s1. And potassium 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Look at these configurations. 2s1, 3s1, 4s1. So the valence configuration is same, no? A common valence configuration. So likewise for other groups also. Group number 2 is beryllium, magnesium, calcium, strontium, barium. Group number 13, boron, boron, aluminium, gallium, indium, thallium. Group number 14, carbon, silicon, germanium, tin, lead. Group number 15, nitrogen, phosphorus, arsenic, antimony, bismuth. You have to remember in that order also, group wise order. Group number 16, oxygen, sulfur, selenium, tellurium, polonium. 17, fluorine, chlorine, bromine, iodine, astatine. Group number 18, neon, argon, krypton, xenon, radon. Likewise, all the group wise elements are, that means elements in the same group have the same chemical properties because of the valence configuration. So that concept is very important for this question. Now, students, we know that I1, I2, I3, I4 means these are the consecutive ionization energies required to remove the electrons from the valence shell. This is the energy required to remove the electron from its valence shell. The first electron, this is the second electron, third electron, fourth electron. Now, how I can decide that? How I can decide whether these two elements, now definitely that one should be a couple, no? B and C, A and B, B and E, C and E, D and A. Whether this couple is belong to the same group, how I can find out? What is the logic behind that one? What is the point? Students, we have to consider the gap between the ionization energies. Can you remember? When we draw the graph, I told you that when we are shifting to another principal energy level, there will be a large energy gap. Right? ඔයා මේ ප්‍රශ්නේ උත්තරයට යන්න ඕන energy gap එකකින්. Right? Where you can find out the largest gap between the 2 points. From that one, you can catch the answer. Right? Students, now let's see. Now I'm going to consider the gap between the values. Approximately, you can take that one. Huh? So just analyze this one. Where we can obtain the largest gap? I think here between these two values, we have a very large gap, isn't it? Between these two values, we have very large gap. It is more than 4,000. It is more than 4,000. The gap is more than 4,000. And here also you can see a large gap, right? Let me calculate that value. 7,740, 1,450, 0, 9, 2 here, and 6. Okay, 6,290. Please mute your microphones. Ayman. Right? Okay. Then students, the gap between these two is 6,290. Again, where you can see the largest gap in C? Where you can see the largest gap in C element? Between 1,760, 4,800. That means here, the gap is 14,800, 1,760. The gap is 0, 4, 0, and here 13. So the gap is 13,000, 13,040. And here you can see the largest gap between I3 and I4. 11,600, 2,740. 0, 6. 5 means 8 here. 8,860. And here, where you can see the largest gap. I think all the gaps are similar, no? We don't have that much of a variation. So here the gap is about 1,060, no? That means this is even lesser than 900, 840. And here the gap is around 1,000, 1,080. And here gap is about, so here the largest gap is about, we can say that, let me consider that one also. But it's not much larger. 2040. Okay, anyhow. Right. Now, these are the largest gaps that we obtain in each element that they have given. Okay, in each element that they have. Students, now you can see, look at C and capital C and capital E. 6,290 compared to the previous gap here, this is very large. Look at this gap value here, 900 and 1,760. So here the gap is actually 860. And here about, let's say that, yeah, this is around 700 again, more than 700. But suddenly it is increasing to 6,209. Here suddenly the gap is increasing 13,040. Then you have to understand that this is the separation of the principal energy levels. Am I right? That means, students, these two electrons are belonging to one particular energy level, and these two are belonging to another one. And these two electrons are belong to another principal energy level, and then these two electrons are belonging to another one. So that is same kind of a pattern neighbor. That means if I draw that graph for C and E, there will be 2 points here, and then suddenly increasing like this for capital C. For capital E also, there will be 2 points like here, and then suddenly it increases. So this is actually what? Separation between principal energy levels. That means these two are the valence electrons. Valence electrons are how many? How many valence electrons are there? 2. And here how many valence electrons are there? 2. Then, like I discussed here for lithium, sodium, potassium, if they are in the same group, their valence electrons patterns are same. 2s1, 3s1, 4s1, 5s1, s1, s1, s1. Same number of electrons. Right? How do you decide these are the valence electrons? Students, we are removing electrons from the valence shell. No? First ionization energy means the energy required to remove the electrons from the last valence shell. The first electron that we are going to remove. In the valence shell, there are 2 electrons, 2 electrons. Then we can consider C and E. The chemical properties of C and E both are same. They are in the same group. So I think A and B also same, students. Now you have to understand like this. Compared to the previous gap between these two, now this is 1,820. Then the gap is 20. So just 920. Right? Compared to 920, 8,860 is very large. Now here the gap is about 1,020. So this is actually just doubled. Right? So therefore we can't consider these two are having the same chemical properties. Compared to the previous one, we don't have much gap here. But this is actually a considerable gap. Considerable large gap. Can you understand what I'm saying? So therefore, can't we say capital C and capital E are in the same group? Definitely we can say capital C and capital E both are in the same group. Question number 9, answer should be fourth one. I saw that many students got the answer as fourth one. Very good. And is this the concept that you use to go for the answer? Yes, Anjali, good. Right, okay. Now, honestly raise your hand those who understood that calculation, that question and my explanation. If you have any doubts, put your doubts in the chat box. So I found all the gaps and then got the answer. It's kind of a waste of time. But I think that now from now, this question, you learn what to do there. Akira. No point of calculating all the gaps. So if you analyze the values, you can understand from where we can obtain the largest gap. Okay. Some of the data points will be there without large gaps. Now, for an example, for capital A, we don't have that much of large gaps. Okay. So you don't have to find out all the gaps for this question. Just by analyzing the values, if you can obtain the largest gap where we can obtain the largest, then I think you can go for the answer in lesser time. You two did the same. Okay, right. That is the way. Okay. First of all, look for the largest gap. That is easy. Students, anything else? Any doubts? Put your doubts in the chat box. Those who didn't understand that. Right, okay, now let's move to the question number 10. Question number 10. Which of the following is the correct expression for the energy range of a photon in the visible range corresponding to the wavelength range lambda 1 to lambda 2, where lambda 2 is greater than lambda 1. Lambda 1 nanometers, lambda 2 nanometers, where lambda 2 is greater than lambda 1. And they're asking what is the correct expression for the energy range. Students, if we consider energy corresponding lambda 1 is E1 and the energy corresponding for lambda 2 is E2. So which one is the largest energy? Is it E1 or E2? If lambda 2 is the greatest wavelength, yeah, E1 is greater than E2 because we learned that energy is directly proportional to the frequency, inversely proportional to the wavelength. Okay, so therefore E1 is larger than E2. Then since they're asking the energy range, let me consider E1 minus 2 because E1 is the largest. Then apply equation. Hc is a constant, lambda 1 minus Hc lambda 2. Now here, now you have to understand that they have given 10 to the power 8 joules, 10 to the power minus 10 to the power minus 19 joules. Planck's constant unit is joules second, and this is meters per second. And then they have given lambda 1 in nanometers, no? So therefore we have to write down this one as Hc lambda 1 is in nanometers, right? So therefore we have to remove that nano, otherwise we can't what convert that one into meters, right? So what we have to do that one in order to convert that one into meters, you have to multiply this one by 10 to the power minus 9. Then it is meters, right? 10 to the power minus 9. Can you understand? Plus they have given lambda 1 using nanometers. No? So therefore, let me multiply that one by 10 to the power minus 9. Then only we can get the unit joules correctly. Ne? Otherwise, meters will cancel off, second per second will cancel off. In order to get the unit in joules, we have to use 10 to the minus 9 minus Hc over lambda 1 into 10 to the power minus 9. Then we can consider E1 minus E2. This is equal to Hc is a common one. 1 over lambda 1 minus 1 over lambda 2. Right? 10 to the power minus 9 will go for the numerator as 10 to the power plus 9 joules. Okay. But we don't have an answer like that, no? Raise your hand those who got the answer like this. Question number 9 answer like this. Question number 10 answer like this. Students, for the question number 10, put the answer all. We don't have correct answer there. 10 to the power plus 9 joule is not there. Question number 10, answer is all. That means you have a free mark there. In question number 11, they have given the compound like x3y3, no? Students, correct that one as x3y2. It's not x3y3. Correct that one as x3y2. Question number 11. Yes, Hana, what are the questions that you have? So why you are subtracting E2 from E1? Because I told you, no, lambda 2 is greater than lambda 1. Then we know that when the wavelength decreases, energy is increasing. Lambda and the wavelength is inversely proportional, right? So therefore, what should be the largest one? E1 or E2? The energy radiation with the lowest wavelength only having the largest energy. Therefore, E1 is greatest. Then E1 minus E2. Understood? That's why I consider E1 minus E2. Students, if you have any doubts, put your doubts in. Let's see. Eleventh one, correct that one as x3 y2. Okay. Right. Raise your hand those who got 10 out of 10. We have 5 more questions, but I want to know that how many of you got 10 out of 10. Oh, good. Again, raise your hand those who got 10 out of 10. Sehara, Shabnam, Zainab, Ahmad. Okay. Right. Now let's move to the last 5 MCQs. Question number 11. X and Y elements form the ionic compound X3Y2. I told you to correct that one as X3Y2. Then students, this is an ionic compound. No? We can separate the cation and anion. We know that when we write down the chemical formulas for the ionic compounds, when there are charges, we consider them as valencies and we exchange those values. Then this one should be X2 plus and Y3 minus. So then only 2 and 3 will be exchanged and X3, Y2 came. Friends, tell me the famous cations and anions you know in this type. For this one, can we take N3 minus? Nitride, simple. Right? X2 plus, magnesium 2 plus. Then magnesium nitride, yes, there is a compound. Magnesium is reacting with nitrogen gas in the atmosphere and producing magnesium nitride, Mg thrice, N twice, yellow white color solid. To balance the reaction, we can put 3 here, magnesium nitride. So magnesium is a group 2 element. Do we have that kind of a configuration? Exactly, they have given magnesium's configuration. 1s2, 2s2, 2p6, 3s2. Then nitrogen configuration is 1s2, 2s2, 2p3. Right? So therefore, what is the answer? 1s2, 2s2, 2p6, 3s2, and nitrogen is 1s2, 2s2, 2p3. Answer is number 5. Question number 11, answer is number 5. Raise your hand those who got the answer as number 5. That is also a very interesting question. Okay. Next one. Question number 12. Which is false regarding atomic orbitals? Question number 12, I think that is statement type of a question. A, B, C, D, they have given 4 statements. Simple A statement. No two electrons in an atom can have the same set of quantum numbers. Is that correct? Yes, it is correct. Electrons are present in orbitals to maximize the energy of the atom. Is that correct? Electrons are present in orbital to maximize the energy of atom. Is that statement correct? Simple B statement. Electrons are present in orbitals to maximize the energy of the atom. Maximize the energy or minimize? Minimize the energy. Remember, students, when the energy is low, when the energy is minimized, that is stable. So therefore, it is always trying to minimize the energy. So therefore, that is false. S orbitals are spherical shape and p orbitals are dumbbell shape. Correct. That's true. Third energy level of an atom has 9 orbitals and it can occupy 18 electrons. Students, third principal energy level is containing how many sub-energy levels? Third principal energy level is containing 3 sub-energy levels, S, P, and D. In S orbital, we know that there are 2 electrons, here 6 electrons, and there are 5 D orbitals. Each orbital is containing 2 electrons. So totally how many electrons are there? 18 electrons are there. Okay. Total number of electrons are 18. Yeah, 2n squared. Yeah, we can use 2n squared equation. No? N equal 3. Then total number of electrons can be 2 into 3 squared. So therefore 18. Okay. So therefore, how many orbitals are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 orbitals and 18 electrons. Correct. ACD statements are correct. If ACD statements are correct, what is the answer? Option number 5. Question number 12. Answer is number 5. ACD, those 3 statements are correct. They are asking false statement, no? Yeah. They are asking which is false regarding atomic orbitals. B statement is wrong. So since B is only wrong, then also answer is number 5. Okay. Students, in the question number 15, there is another mistake. In the question number 15, they have given C statement, charge of an alpha particle. In C statement, they are giving charge of alpha particle. Correct that one. Charge of an alpha particle. Question number 15, C statement is charge of an alpha particle. Right. Now let's move to the question number 30 regarding the hydrogen emission spectrum. Which of the following statements are true regarding hydrogen emission spectrum? True statements. Spectral lines with highest frequency are found in the visible region. That's wrong. That's wrong. Highest frequency belong to the Lyman series, ultraviolet region. Simple A statement is wrong. You have to understand that one. A green color line is observed when electron transits from second principal energy level to fourth principal energy level. Second principal energy level to fourth one. Is that second to fourth or fourth to second? Balmer series, no. So a green color line is observed. They're asking about the emission spectrum, right? A green color line is observed when electron transits from second principal energy level to fourth principal energy level. Students, that statement is wrong, right? Because in the emission spectrums, we know that the electrons are falling to the lower principal energy levels from higher principal energy levels, higher energy levels. So therefore, the statement that they have given, we cannot accept that, right? So these are the Lyman series lines here. So then Balmer series means from higher energy levels to second principal energy level, right? H alpha, H beta, H gamma, H delta. So they are talking about the green color line. So green color line means n equal 4 to n equal 2. So that's wrong. We can't accept this one. So second statement is also wrong. So let's go for the statement C. Spectral lines get closer in the direction of increasing frequency, and the gap between two series also increased. That's correct, right? They have given the spectral lines get closer in the direction of increasing frequency, and gap between two series also increase. Students, I told you this one using the values, right? So when we draw that spectral line diagram, right? Now let me erase this one. I hope you don't have any doubts in the energy level diagram, right? This is the energy level diagram. Now let's move to the spectral line diagram. In the spectral line diagram, we know that lines are approaching to each other, that means the gap between the lines are decreasing for the direction where energy is increasing, or else frequency is increasing. In this way, this is the Lyman. So we consider this is Lyman, right? Then let's go for the Balmer series. This is Balmer. And then Paschen. Paschen. And then Brackett. Right? So this is the direction where energy and the frequency both are increasing. So as they say here, spectral lines get closer in the direction of increasing frequency, and the gap between two series also increase. Students, here you have to consider that this is the gap between Lyman and Balmer. This is the gap between Paschen and Balmer. And this is the gap between Brackett and Paschen. So the gaps also increasing for this direction. For this direction, the gap is decreasing because energy levels are getting closer to each other. No? So therefore, the required energy is very low. So therefore, the values can be get closer. Right? I explain you by drawing the x-axis and how the values are changing, right? I hope you can remember these things. Remember, students, for the direction where frequency and the energy increases, the lines in each series are getting closer to each other. Even the next thing is the gap between the each series is increasing for the direction where the energy and the frequency is increasing. Right? So these are the gap between the series. This one, this one, this one. C statement is correct. What about statement D? A spectral line does not display an energy level. That's correct. Right? A spectral line is representing the energy gap between the energy levels, the emitted energy, right? When it is transferring from high energy level to low energy level. So they're asking true statements C and D correct. Question number 13, answer is third one. Raise your hand, those who got the answer as third one. Okay, good. There are some students. Right, okay? Are we done? Question number 14. Consider the given statements about nitrogen atom. electron configuration is 1s2, 2s2, 2p3, and the orbital diagram is they have given 1s, 2s, 2p. Orbital diagram is also given. So they have given some informations about nitrogen. Quantum number set of a p electron, 2p electron is 2, 1, 0 plus half in this way. So the principal laws which are important for the data presented about regarding the nitrogen. Number one, Aufbau principle. Friends, here actually Aufbau principle is not important. Why? This is correct energy level load up to nitrogen 1s2, 2s2, 2p3. So Aufbau principle is actually not important here, right? So they're asking the principles or the laws which are important for the data presented about nitrogen. So Aufbau principle is not important here, right? Simple B Hund's rule. Yeah, that is important because in the Hund's rule, we discuss about how the electrons are filled to the p orbitals and d orbitals one by one, because someone can write down these electrons as like this 1, 2, 3 likewise. Then that is wrong. Then Hund's rule is important for writing the correct way that electrons are filled to the orbitals. So therefore, even though Aufbau is not important here, Hund's rule is important. C. Pauli's exclusion principle. Yeah, Pauli's exclusion principle is also important because we know that the maximum number of electrons can occupy in an orbital is 2, right? So that is followed in 1s and 2s. And each electron have two different, that means no electron can have the same sort of quantum numbers. They have given the quantum number set also, right? Our next big topic is quantum numbers, right? Quantum number is representing the principal energy level, sub energy level, orbital type, and the rotation of electron. So therefore, here they are explaining the Pauli's exclusion principle as well. It's okay. Bose theory, students, this is not the hydrogen emission spectrum to discuss about the Bose theory. So anyhow, there is no connection between the Bose theory. B and C correct. Question number 14, answer is second one. Raise your hand those who got the answer second one. Raise your hand those who got the answer second one. Right, okay, last question. Charge of an electron is minus 1.602 10 to the power minus 19 coulomb, correct? Simple B, charge of a proton is plus 1.602 10 to the power minus 19 coulomb, that's correct. C, charge of a alpha particle. Students, alpha particles means helium nucleus, right? Helium nucleus means helium 242 plus. So what is the charge? So that means 2 plus means 2 protons. So therefore we can consider that this is twice the 1.602. That's also correct. D, look at the D statement. The charge of a single particle which travels towards the anode. Students, tell me which is traveling towards the anode. If a particle is traveling towards the anode, it should be a negatively charged particle. Am I right? If a particle is traveling towards anode, it should be negatively charged particle. But the answer that they have given is positive. So from that point, I can reject the answer. But let's read continuously. the charge of a single particle which travels towards the anode within a tube that generates canal rays, okay, filled with hydrogen gas consisted of tritium. Tritium means one of the isotopes of hydrogen. Hydrogen 1 3, 1 electron, 1 proton, and 2 neutrons is plus 4.806 10 to the power minus 19. Students, now this is actually it's a very silly statement, right? Just by having neutron, will the charge change? Just by having tritium, deuterium, or protium, will the charge change for the canal rays? Now these are canal rays. From hydrogen, canal rays are produced. Whether it is deuterium or tritium or protium, charge won't change. H plus means H plus. Only the physical properties are changed. So therefore, that is very wrong here. They have given 4.806. Therefore, that's wrong. And the next point is, as I said you, if the particles are moving towards the anode, they should be negative, but they have given positive. This statement is wrong. A, B, C, three statements are correct. D statement is wrong. Question number 15 answers number 1. Right. So these are the questions that we have to discuss today. Okay, students, raise your hand, those who got 15 out of 15s. Anjali, very good. Only Anjali. What about the others? Very good, no? Anjali, give it up. 14 out of 15. Okay, raise your hand. I want to know that. Shabnam, Joella, Ahansa, Zainab, Harini, Takira, Shehan. Good. Okay, very good. Then, raise your hand those who got 13. Vinodi, Hana, Umaya. Good. Right. Okay, Joella, 14, no? Very good, no? If you can score more than 13, 13 or 13, more than 13 or 13, I think that will be a good mark for this paper. It's really good. Keep it up and try to get always more than 10 at least in a memory booster paper if I have given you 15 MCQ, right? So the next week also we are discussing another 15 MCQs. In the next week paper, probably I will categorize them like first five MCQs are normal typical questions, and the second five is ABCD five, and last one is the table. Likewise, I might categorize them to get an idea about those questions. Okay, type of the questions. Right. Okay, now raise your hand those who understood the things that we discussed today. Do you have any doubts? I think this is also a very good paper. If there is no error in the question number 10, this would be a nice paper, but it's okay, fine. Some other questions are there, really interesting. Let's see. I hope to discuss more MCQ questions with you. Okay, then students, I'm going to wind up the session for today. Next week, let's meet on the theory class, and next Saturday, we will be discussing memory boost paper number 7. Okay, right. Do you have any doubts then? Anything? All clear? Right, okay. Then students, let's meet on the meet on the next week class. Until then, bye bye, have fun. God bless. Good evening.